Hello everyone, in this video we will see how to write a recursive functions in Python. Okay, so what is a recursive function? If a function gives a call to itself, then that particular function is called as a recursive function. Okay, let's discuss this with the help of example. So very classic example to explain a recursion is to find out a factorial of a particular number. Let's say I want to find out factorial of 5. Okay, so same thing, I can write it as 5 into factorial of 4. Same thing, I can write it as 4 into factorial of 3. Same, I can write it as 3 into factorial of 2, and it can be written as 2 into factorial of 1, and answer for factorial of 1 will be 1. Okay, so here we are just changing a number and performing same operation, right? So such problems I can solve using recursion. So let's take a number equal to 5. I want to write a function called factorial. If I pass a number to this, it should return me an answer, that is 120. Okay, so print result. Okay, if you see here, our one step is if your number is 1, then I need to return the answer 1. Okay, otherwise I just need to check a number. If it's not 1, then reduce it by 1. So let's try to write a logic for this. So I'm writing definition of factorial and I'm passing this number. So I am checking if this number is equal to 1, then in that case answer is 1. So I am saying return 1. Else I am saying return number into factorial of number minus 1. Okay, if I execute this, I will get answer 120. So let's try to debug the same code and let's see how recursion works. So initially I am saying factorial of 5. So I'm making one function call, that is, this is the first function call, factorial of 5. I will check if this number equal to 1. No, go to the else part and I'm saying return number into factorial of number minus 1. That means here I am saying 5 into factorial of 4. Okay, so again this is a function call. Now Python will start executing from top again. Okay, so number is 4. Now it will again compare 4 equal to 1. No, then go to else part. Now write number into factorial of num minus 1. So now this is 4 into factorial of 3. Again check. So again this is a function call. So this will be 3 into factorial of 2. Next time this will be 2 into factorial of 1. Now when I am making a function called factorial of 1, it will compare a value here, num1 equal to 1, then return 1. Okay, so answer I will get as 1 and there is a return statement. Okay, now there are 5 function calls. So when I say return, where exactly it will return the answer? Okay, so it will always return result to its immediate caller. So it will calculate the result 1 and return to its caller. So he is calling this particular 1, so it's getting a call from this particular function. So it will return answer 1 here. Evaluate this. So here I will get answer as 2. Now this 2 will be returned to its caller. Who is the caller? Factorial of 2. Alright, I will get 2 here. Now what will be the answer? So 6 will be so it will evaluate the 6 and it will return the result to its caller. Who is the caller? Factorial of 3. 6 here. Calculate the results. I'll get 24. 24 will be returned to its caller. So here I'll get 24. Evaluate this, I will get answer as 120, and now this is the final function return call. So it will return the final function call here. Okay, so like this I can write a recursive function in Python. So I just need to provide a function call and pass the required set of arguments. Okay, so let's try one more problem, and that is binary search. So if I have a list, or if I have a sorted list, and if I want to search if a particular element exists or not. Let's say I am looking for key as 700. I need to check if 700 is present or not. So we have discussed linear search, that is, I am comparing each value. So I will compare 100 with 700, 200 with 700, 300 with 700 and so on. So total number of iteration which we need in case of linear search are more. So for efficient searching, I can use binary search. Now what is approach of binary search? So first thing is I need to count the middle index. Okay, so now here I have 9 elements in the list. If I calculate 9 by 2, I will get 4 as the answer. So ignore the decimal part, I will get 4 as the answer, right? So what will be the fourth index? That is 0, 1, 2, 3 and 4, that is 500. Okay, so this will be mid. So I got fourth element will be the mid, so value is 500. So I will compare this 500 with the key. Okay, if this mid is equal to key, then in that case I will say return true. This is the answer. Okay, otherwise I need to check if this key is greater than mid or less than mid. Now as array is sorted or a list is sorted, so I can definitely say if the element is greater than mid, then if it's present, then it should be on the right hand side of the mid, or if the key is smaller and if it's present, then it should be on the left hand side of the mid. Okay, so next time what I will do, here in our case key is 700, mid is 500. That means my key is greater than the mid. So in that case I need to check for all the elements which are present on the right hand side. So what I will do now, I will reduce a list to 600, 700, 800 and 900. Okay, now this is a new list and here I need to check if this key exists or not. Okay, again I need to calculate the mid. So what is mid now? I have 4 elements, 4 by 2, I will get answer as 2. What is the second element? That is 0, 1 and 2, 800. Compare your mid, that is 800 with your key equal to 700. No. Then in that case again compare if it's less than mid or greater than mid. So in this particular case it will be less than mid, right? So in that case now I need to reduce the list again, everything which is present on the left hand side of the mid. Now my new list will become 600, 700. Okay, again I will calculate the mid. So mid will be 2 by 2, I will get answer 1. So what is the element present at first index? That is 700. Compare 700 with 700. Yes, I got the result. Then I will say return me the answer true. Okay, so here if you see I am again and again performing the same set of operation. That means I am calculating the mid, I am checking if it's equal to mid or not. If not, then check if it's greater than mid or less than mid. Okay, but just on a different set of list. So that is the reason I can now solve this problem using recursion. Okay, so let me write a function called binary search. So I am saying binary underscore search, pass the list and key there. Okay, so this function binary, so this function should return me true or false. If key is present it will return true, else it should return false. Okay, so I'm trying to print the result. Okay, so let's try to write a definition for this. So definition of binary underscore search, pass the list and pass the key. Okay, so first thing I need to do is calculate the mid. So how I can calculate the mid? So I can say mid is equals to calculate length of this list and by 2. Keep in mind I cannot use division here in Python version 3.2. Reason, your Python division will always return your floating point number and I want to use this mid as an index, so I need an integer value only. So that is the reason I am using a float operator here. Okay, I need to check if middle element is equal to key or not. So I'm saying if, now I have an index of middle element, so I'm saying L of mid is equal to key. If this is the case, then return the answer true. Else, so I need to check multiple conditions, so I'm writing elif. I need to check if key is less than L of mid. Okay, if this is the case, that means if key is less, then I need to check for the key on the left hand side, right? So here I'm saying if that is the case, then binary search, I need to pass everything which is present on the left hand side. So here I can use slicing. So I'm saying now pass all the elements starting from start of the list to mid, and I need to pass a key as well. Okay, now when I'm making a recursive call, if I'm reducing the list and calling the same function, I need a result of this function too, that what is the final answer. So because of that I need to write a return here. Okay, otherwise I will say return binary search of L of mid. I need to write L of mid plus 1 because I have already checked the middle element and it is not equal to the key, and that is the reason I am doing the further comparisons, right? So I will write from mid plus 1 go till end of the list, and this is the key. Okay, so now let's try to execute this. So it is returning true. Let's try something from left hand side, say 100. Okay, so it looks like it is working, but we haven't handled this condition. Let's say if element is not present. Okay, so now it is throwing me an error saying list index out of range. Okay, why is that? So let's try to find out. So now when I say key is equal to 1000, right, I will start calculating mid. So I got a middle element as 500. I will compare 1000 equal to 500, no, then pass the list which is present on the right hand side. Okay, so from 600, 700, 800 and 900, calculate the mid again. What will be the mid? So I'll get 0, 1 and 2. So okay, 800, compare 800 with 1000, no, key is still greater, then pass everything which is on the right hand side. Now I have a single element in the list. I will calculate the mid, that is 1 by 2, I will get 0, I will check with 0th element. Compare 900 with 1000, no, key is still greater, then pass everything which is on the present on the right hand side of it. Now here your list is empty, and that is the reason if I try to calculate mid on empty list, it will throw me an error saying list index out of range. Okay, so how to handle this? I am saying if len of this list, if length of the list is equals 0, then do not calculate the mid, return me the answer as false. Okay, otherwise calculate the mid and again recursively give a call to binary search function. Let me adjust the indentation. Alright, now let's execute. Now it's returning me false. Let's try for the element which exists. Okay, so our code is working. So this is how I can write a recursive functions in Python.